Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signal and System Analysis. In this video, I will continue our discussion on inverse Fourier transform. Okay, so in this slide, I will show you the solution to the first sample problem regarding inverse Fourier transform. Okay, so the question asks you to find the inverse Fourier transform of the signal given in this figure, okay, which is x omega equals to omega square. So the equation for the inverse Fourier transform is x of t equals to integration, okay, let me just write here. X of t is equals to 1 over 2 pi integration from minus infinity to infinity for x omega e j omega t d omega. So in integration with respect to d omega. Now if we look at our graph here, okay, we know that x omega is equals to omega square when omega is in between minus omega naught to omega naught. Okay, so we can replace the equation and the limit in this inverse Fourier transform equation. So we will have x of t equals to 1 over 2 pi integration from minus omega naught to omega naught. X omega is omega square e j omega t d omega. Okay, so now what you have to do is integrate this part. So let's just say I bring out, okay, this. Let's integrate this first, and let's just omit this 1 over 2 pi and the limit, okay, to make it easier. So what we can do is we can apply the integration by part. I hope you still remember in your calculus class, I think, in one of your math class, you study integration by part. Okay, where you have the general formula is uv minus integration of v du. Okay. So let's say in this case I choose, you can choose either omega naught or ej omega t as your u. Okay, similarly you can choose either one as your v. Okay, but you wanted to make sure that whichever you choose for your u or your v, it will be the one easier, okay, for you, the one easier to differentiate, and the one that you choose as you wanted to choose dv, okay, then you will integrate to get v. So the one that you choose as dv is the one that is easier to integrate. So let's say for this one I choose u omega naught as u, and dv is e j omega t. Okay, so here what you wanted to do is you want to differentiate. So you du you will have 2 omega, and this one you wanted to integrate. Okay, so you integrate this one with respect to d omega. So you will get v, which is equals to e j omega t with respect to omega. So you will have over jt. Okay, so next you substitute this u and v into this general equation. Let's say equation number 1. Okay, so you will have u, which is omega square, v is e j omega t over jt Now minus integration of v, which is e j omega t, and there is jt. So let's say I bring this jt outside because it is just a constant. So you have integration e j omega t du is 2w, 2 omega. This one with respect to d omega. Okay. So now we have these two again. So you can choose again. Okay. Do for this part. Okay. Do again integration by part. Okay. So let's say this time I choose u to be 2 w. I choose okay, because this 2 is constant, so actually we can bring the 2 outside. Okay, so then u, so before that let's just rewrite this again. So I have omega square e j omega t over jt minus 2 over jt. So now is integration for omega e j omega t d omega. Okay, so now this part. Okay, so let me just do this. So this part is the one you wanted to again apply integration by part. So let's say this time I choose u to be omega and dv again e j omega t d omega. So my du will be d omega, and if I integrate this, I will get v equals to e j omega t over jt. Okay, so again you wanted to replace uv into the general equation of the integration by part, which is uv minus integration of v du. Okay, but remember you have this part, okay, at the front, so we have to write them, all of them. Okay, so you have omega square e j omega t over jt minus 2 over jt. Now this u and v, so you have omega e. Okay, so this you multiply, you get omega e j omega t over jt minus integration for v e j omega t over jt du. Du is d omega. Okay, so now you can easily integrate this part, right? So you get omega square e j omega t over jt minus 2 over jt omega e j omega t over jt minus, if I integrate this, okay, I will get e j omega t over jt square. So next is you multiply them, all of them, so you get omega square e j omega t, okay, minus jt, you will get minus this one 2 omega e j omega t over this one will be jt square. Okay, and this one minus with minus, so it will be plus 2e j omega t over this jt cube. Okay, so if I make the denominator equal, okay, let me just draw a line here. So if I make the denominator equal, so I will get here by multiplying all with here multiply with jt square, and this one multiply with jt. Okay, so I will get omega square e j omega t. So this one you multiply with jt square minus 2 omega e j omega t. This one you multiply with jt. This one remain as it is, j omega t divided by jt cube. Okay, and we know j square is 1, so then this will be simplified to let's say omega square t square e j omega t minus 2j omega t e j omega t plus 2e j omega t over jt cube. Okay, now this one, okay, you have to put it back in the original equation. Okay, or if you still remember, we have x of t. So let me just open a new page. We have x of t equals to 1 over 2 pi. This one is from the beginning. Okay, minus omega naught to omega naught of omega square e j omega t dt and d omega. Okay, so now we have to substitute, okay, this part, well actually the whole, okay, integration with this one, okay, with this one. So if we do that, means we have x of t equals to 1 over 2 pi, okay, and then we have if I take out the common expression, I will have e j omega t over jt cube, okay, and multiply with omega square t square minus 2j omega t plus 2, and the limit of the integration is from minus omega naught to omega naught. Okay, so now what you have to do is replace omega with omega naught and minus omega naught. You know how to do that. If you do that, then you get the answer is x of t equals to omega naught t square minus 2 sine omega naught t plus 2 omega naught t cos omega naught t divided by pi t square. Okay, so this is the inverse Fourier transform of the given signal. Okay, so which is in the time domain. Okay, so that's all for the video this time. I will see you in another video for another sample solution on inverse Fourier transform. Thank you.